Okay, so what we're going to do is we're going to do the first graph, and then we're going to do the absolute value of it, just to remind you what absolute value does. All right, don't make me talk over you, especially since I'm making a video for people who are absent. So let's do the transformations first. You are welcome to pull this up on your calculator since you have your calculator out. This is one of those things that I also have sheet for this quiz. And this quiz is going to be a kind of maybe one or two columns on the back of inverses, and then it's going to be like a random little half sheet that you can use your calculator on, and that you can double check these absolute value problems with your calculator. So 2 sine of 4x, what would the period of this function be? Yeah, pi over 2. Pi over 2. So we have a period for this one of pi over 2. We have a vertical stretch of 2, so let's make that happen just normal time. So here, halfway in between we're going to go up to 2, halfway in between we're going to go down to 2. Again, I would definitely get used to checking things on your calculator. It's a little bit of a challenge for me because everybody's calculator is so different. As I walked around, some of you, your calculators are defaulting to negative 2 pi to 2 pi. Some of you, your calculators are going, 2.5 pi to 2. And so getting to know your calculator and how it works is important. Okay, vertical stretch of 2 or amplitude of 2, and then period of pi over 2. So what does absolute value do? It makes all your y values positive. Absolutely. Every y value becomes positive. So what it's going to do to our trig graphs is it's going to take this midline and we're going to bounce off it. So instead of going like a wave above, below, it's going to go above, above. It's kind of fun, yeah? Thanks for agreeing even if you didn't agree. Okay, so instead of going below the x-axis, it's going to feel funny. But one period, and when I do this without, like if I hadn't just graphed everything else on its own, I would do this. I would kind of dot in, and then I would do this. Boom. And I know that one's going to do that. And it's just going to keep going. Because remember, the definition of absolute value is just that we are making everything up. So, how do you put that in your calculator? Well, on the TAE4, which is like probably more than half of you, absolute value, this is what you're looking for. And it is if you press the math button and then go over to number. Absolute value is number 1. And so you can just put that in first and then any function you want, whether it's sine or cosine or, heaven forbid, tangent. On the Inspire, under the book. Ooh, where's that? Control equal sign on the Inspire is the fastest. Oh, maybe. What if you go under the little book?
I think the book.
Go under the book. Oh. Because it's in alphabetical order.
It's under the book. It's that top one.
It's the very, so you have to Cool, so on the TI Inspire, if you go under the little book button, here are my artistic skills. Right?
Hey!
It's pretty good, right?
That's solid.
A book.
Oh, okay.
Whatever you a butterfly?
Yeah.
It
also works with so I
I thought it worked when we just typed it in, so I wasn't.
you can just like type it inside.
Right.
Okay.
Let's do another. Here we go. What transformations are happening here? Okay, last pi over 2. Left pi over 2, we're going to reflect over the x-axis. And we have an amplitude of 2.
Yeah.
So I'm going to start left pi over 2, so my starting point is going to be over here. I'm going to start at a minimum since I'm reflecting over the x-axis. And what's the period of the function? 2 pi. So where am I going to put my next dot? Well, where am I? Like, I like to do start and end. Where's one period of this function going to end? Yeah, 3 pi over 2. So really, one period of this function is going to go from negative pi over 2 to 3 pi over 2. Again, you can double check this all on your calculator now. Now, these points that I'm plotting underneath here, since I only gave you one graph for this, I'm just going to dot in, and then I'm going to do everything above the x-axis to do that absolute value function. Okay, halfway in between for cosine, we have a maximum. So 1, 2, 3, 4, and then I'm going to go up to positive 2. Oh, this would have been much easier as a sine graph. Right through 0, 0.
How would that work? Once the sign is still moving over. Like if it's a sign.
Well, if it's a sine, if we're a sine equation for this, wouldn't have a phase shift. It would just start. You could start it at 0. Okay, so here-ish. That balance now. Okay. Okay, so my absolute value graph is just going to bounce up. Anything below here is going to go above. Anything below is going to go above. So I'm going to go ahead and recopy my nice above x-axis curves. And there's the absolute value. And here's how it looks on the 84. So when I'm checking these, I make sure that my window is the same. So since my window that I'm graphing it up here is negative 2 pi to 2 pi, when I put in the scale, I make my x min negative 2 pi, and my x max, I make it 2 pi. And like I showed a lot of you, you can just type that in using that pi button. If you get an error, if your calculator starts to freak out on you, just go back to Zoom Trig and try again. Because a lot of times I will forget to put the negative with the 2 pi, and then it'll be like, you want me to start it into the same place? No. And I was tell the calculator that I'm the boss of it and take it back to Zoom Trig and then try again. So you can't really break these. You can do things that they don't like. And so just practicing getting yourself kind of out of that bind, especially with Trig, is a good thing to do. So Zoom Trig if you get an error. I usually don't play with my y's because really all I'm doing for this is counting those maximums. Negative 2 pi to 2 pi, I should have 4 of them. Negative 2 pi to 2 pi, I have 1, 2, 3, 4. I'm pretty happy. That's really what I'm doing when I'm checking. If I'm checking something like this, I would scale in my calculator negative pi is my x min. and my x max at pi, and then I'm either just going to count the peaks or count the valleys. Like I would just go 1, 2, 3, 4, and make sure my calculator picture has 4 peaks. And as long as they kind of line up, I'm good. So that's how I use my calculator to double check. Yeah.
So what buttons do you use like for absolute value, like the
You do on your calculator math, and then you go over to the number menu,
oh,
and then absolute value is number 1.
okay.
Okay, one more. Gotta look at a tangent. Can't look at sine and cosine without looking at a tangent.
Entered into the
Spoiler alert. Apparently I didn't want to graph it by me on last year. Got leave. Okay, negative tangent of x minus pi over 2. What are the transformations that are happening? Hang with me for like 2 more seconds.
Jasmine, you're so funny. Thank you. You're so amazing as a person.
So I'm going to move that point, I'm going to move my full function from being centered at 0 to centered at pi over 2. You guys are being rude to me while you're being nice to each other. Just throwing that out there. Okay, so what's the period of tangent? I moved my center over pi over 2. The period's pi. So if I'm centered around pi over 2, then my asymptotes are going to be at 0 and a pi. Again, this looks very similar to cotangent already. And then halfway in between, so they don't have a stretch or anything, halfway in between these two, well, it's like 2.5, I'm at 1. Halfway in between these two, I'm at -1 to get that flip going, right? Because tangent usually looks like that. So we just flip this. Here's the thing though, does that flip really matter if we're doing the absolute value? No, because anything below, we're going to bounce up. We're bouncing off. Bouncing off the x-axis. With this phase shift, yes. Normal, if you were just doing absolute value of tangent of x,
Oh, it would be.
yeah,
This is the parabola.
it would look like that with your one. And again, especially with tangent, with a phase shift, since we didn't do a ton of that, I would double check that. Again, I'm scaled -2 pi to 2, or I scaled this -pi to pi, just like, I always try to match my picture. Basically, I make my x scale exactly the same so I can just count. Alright, there's some practice on the next page I think would be good for you to do, just so you can get it comfortable. Okay.
But,
Just